Auto mesh volume designates a function of visual FEA to generate meshes in an unstructured three-dimensional space surrounded by surface meshes. The surface meshes should be composed of 3-node or 6-node triangular elements. There are no additional conditions for the shape of the boundary surface meshes, as long as they form a closed volume. If the surface meshes cannot form a closed three-dimensional space, the mesh generation will be failed. Either 4-node or 10-node tetrahedral elements are generated, depending on the number of nodes in each of the surface elements. The first example is the case of a volume of dodecahedron, surrounded by 12 planar meshes. Let's start from the boundary curves, which correspond to the 30 edge lines of a dodecahedron. Divide each edge line into 8 segments. Next step is to generate the boundary surface meshes of pentagon shape. Choose Auto Mesh Surface item of Mesh menu. Auto Mesh Surface dialog appears. Place the cursor over a pentagon region. The region is highlighted in green color. Click the region. Then, the region is highlighted in blue color, which indicates the selection of the region. Click Generate button of the Auto Mesh dialog. Then, the pentagon region is filled with 3-node triangular elements. A mesh can be generated by a single step of simply double-clicking a region, instead of 2 steps, that is, selecting a region and clicking Generate button. This single step will be used to generate the meshes on the rest of the 12 pentagon regions, one after another. Now, the surface meshes are completed, and form a closed space of dodecahedron. Choose Auto Mesh Volume item from Mesh menu. The Mesh dialog pops up. Select all the surface meshes, forming the closed boundary of a dodecahedron volume. Click Generate button. A volume mesh is generated. The inside of the volume mesh can be visualized using the clipping plane function. Press the tool button of clipping plane. The image represents the element cross-sections on the clipping plane. It is also possible to visualize the shapes of the tetrahedral elements, sliced by the clipping plane. The clipping plane can be moved in parallel. The image indicates that the elements are generated with relatively small variation in their sizes. There is an option to change the variation of the element sizes. Select the volume mesh and delete it. Let's regenerate the volume mesh with the other option for the element sizes. Click Options button of the Mesh dialog. There is an item of adjusting the variation of element sizes in the option dialog. Click Large Radio button. This option will make the element sizes to vary largely. Close the option dialog and regenerate the mesh again. Clipping plane image shows larger variation in the element sizes. The image on the screen shows the comparison of the results obtained using the 2 options for variation of element sizes. The next example was created from 2 surface meshes. Each of the surface meshes was generated independently, using the method of curve revolution. And then, 2 surface meshes were connected by stitching each other along their intersection line. This process will be demonstrated. Choose Intersect item from Edit menu to carry out surface mesh intersection. Then, Intersect dialog pops up. Set the intersecting object type to surface mesh. Select the 2 surface meshes. Click Intersect button of the dialog. The intersection line is created between the 2 surface meshes. At the same time, there appear remnant meshes as byproducts, which should be removed for volume mesh generation. Select the remnant meshes, and delete them one by one. Now, the 2 surface meshes are connected as an integral boundary surface of a volume. There are 2 openings at both ends of the boundary surface meshes. Let's generate additional surface meshes to seal the openings. Choose Auto Mesh Surface item from Mesh menu. Placing the cursor over an opening makes the surface region highlighted in green color. Double-clicking generates a surface meshes sealing the opening. Thus, the surface meshes form a closed three-dimensional space, ready for auto volume mesh generation. Choose Auto Mesh Volume item from Mesh menu. Auto Mesh Volume dialog appears. Select all the surface meshes and click Generate Mesh button. A volume mesh is generated. Check the inside of the volume mesh, using the clipping plane function. First the image of the clipping plane, with the element cross-sections, and the shaded image of tetrahedral elements, sliced by the clipping plane. Move the clipping plane in parallel, to visualize the volume elements throughout the mesh. The last example is a case of long and narrow volume, with relatively complex shape. The boundary surface meshes have been completed in advance, using intersection of surface meshes. Start Auto Mesh Volume function by choosing Auto Mesh Volume item from Mesh menu. Select all the boundary surface meshes at once. Click Generate Mesh button of the Mesh dialog. The volume mesh is created. Let's check the inside of the volume mesh, using clipping plane function. The elements in various parts of the volume are being displayed, along with the clipping plane, being moved up and down. The direction of the clipping plane can be changed, by double-clicking an edge of the bounding box. The clipping plane is now being moved front and back, so that the element image of the long shaft section can be visualized. This is the end of the tutorial for auto volume mesh generation.